Good morning. My name is Rosa Orenstein. I'm the chair of the North Texas Renewable Energy Group. And I want to thank everybody who's attending virtually today. I see most people that have attended in the past. I think I recognize all the names. If you're new or it's the first time you're here, welcome to our Little Groups meeting. We have a terrific presentation today by Mr. Tony Robinson, but the usual progress for our meetings is to start with our membership meeting first and then have our presentation. I want to thank our sponsors, Dallas College. Can you go to the next slide, please, Michael? Dallas College, which was our terawatt sponsor for the solar tour. The city of Dallas was a megawatt sponsor. We had kilowatt sponsors, Skygate Solar, in Sustainable Systems of Texas. Green Source DFW has been a very long time media supporter of ours. So has Natural Awakenings, as well as the Fort Worth Star Telegram. Restorative Farms was a sponsor of the solar tour this year. We generally collaborate with the Sierra Club, who are also sponsors, as well as 350 Dallas, the North Texas Electric Auto Association, the Tesla Owners Group. I've been remiss in mentioning the Climate Reality Project because they are a group that we try to collaborate with as much as we possibly can. And the Dallas Electric Club, thank you to all of them for sponsoring and helping us move our mission forward as part of the DFW Solar Tour in the North Texas Renewable Energy Group. We're gonna start out with some updates. Lissa, do you wanna take it from here?
Sure, let me turn on my video and unmute. Hi, I'm Lissa Magel. I'm the membership coordinator for NTREG. Just want to welcome everybody who's here already and arriving as I look at the participants. Just want to thank everybody for being here and invite you to become actual, most of the people's names I see are actually members of NTREG. I recognize you, but if you're not, membership is only $20 a year in NTREG, and it helps us support things like these virtual meetings. Of course, we're trying to at some point get away from virtual meetings, and sometimes we have to pay for venues, and so memberships are very helpful for that. If you've been a member and you're curious about when your membership expires, just send me a chat message today and I can look you up and let you know how current you are or when your membership might be due. Rosa will probably touch on this, but we're really hoping that things will open up this spring. And so there'll be a lot more opportunities to get together and actually do things, like we're hoping to participate in Oak Cliff Earth Day and other Earth Day events coming up. So we'll probably have to revamp our booth supplies and things like that too. So that $20 a month will be $20 annual membership will be very helpful. I will let you go, get back to Rosa, and eventually to the presentation. Thanks. Goodbye.
Thank you, Lissa. Yes, as we indicated last month, we are working towards resuming in-person meetings. It looks like the Omicron variant of COVID-19 is going down. Let's hope it doesn't rear its ugly head again and that we can all start meeting in person to some degree or another. So we are working on that. I know the new board, as it comes in, will help the framework on how we're going to do that, and more to come on that as we move forward. But that also means that we will be needing more of your energies, because as you might recall in years past, we have to staff booths such as the Oak Cliff Earth Day with volunteers so that we can continue spreading the message of renewable energy in NTREG. In the meantime, as you all know, we had elections. Every year we have elections. About half of our board rolls in and out every year. And this year was a little bit more challenging because we had a couple more positions to fill. but nonetheless, we had our elections, and Dan Lipinski was gracious enough to run the election for us. And Dan has our report of who our new board members are going to be. So Dan, can you take it from here?
Be glad to.
Dan, would you like me to stop the share so you can share your screen?
No, actually, you're fine just the way it is. We're good. As Rosa just pointed out, we had a couple of additional positions. Normally, half of the board members, everybody serves a 2-year term, and half are elected in odd years and half are elected in even years. We had a couple of additional positions, but I'm pleased to announce, number one, that we actually had a surprisingly high turnout for the elections. Where you normally talk about, gee, we had a 20% or 30%. We did exceptionally well this year as far as getting ballots returned. That said, allow me to announce the results. Everyone was elected unanimously, with one exception. And that being that person didn't vote for himself, but he knows who he is. Rosa has served as our chair for 2 terms and has done phenomenally well. I'm pleased to announce that we have a newly elected chair effective today. Mark Whitty was dragged from the outwoods of the Big Bend country back to the big city, only to discover he is now chair. We have 2 new program co-coordinators, and boy, if that isn't a fun word to say. We have Paul and Bill, whom everyone saw on the ballot. Bill Byron, Paul Whitman. Excellent. Well, I'll tell you what, I think we've got an excellent incoming board. Robert Lagerblad is going to be our event coordinator. Our members at large are Amy Sue and Phil Timmons. And the remaining board members, our treasurer stayed on. He had, the position was uncontested. That would be Michael Fladmark. We also have Eric staying on as our secretary, which he's done a phenomenally good job. I'm pleased to announce anyway, we have a 100% full board and everybody that was on the ballot got elected. So we'll be updating the website shortly, putting the new people's information up as soon as we can get it posted. But congratulations to everyone who got elected. I am very, very pleased with the people that I know that I am seeing coming in. I think we're in for a very good future with the newly elected team. Thank you, Rosa.
Thank you, Dan. And I'm sure this Lisa is staying on as membership coordinator. And we want to thank Lisa for her tireless support and efforts with NTREG. I want to congratulate everybody, Mark, Bill, Paul, Roger, Amy, Mr. Timmons, and Michael, Eric, and Lisa. As you all know, for the last few months, I have been asking for volunteers to step up, and I want to thank all of you for stepping up and helping NTREG move forward. I know that it is in great hands with everybody that I have visited. I am most pleased with the direction that NTREG is going to take with this new energy and new ideas that are going to be coming in with all of you. Thank you so very, very much. I think this is great.
Thank
you, Tony. Thank you all. And I want to thank you. I was going to leave it till the end, but thank you for letting me be your chair. I know it means a lot to me that all of you continue to have the trust in me to continue to lead this group for a couple terms. Thank you all very much for your support. One of the new initiatives we undertook this past year was the internship program. And we have that open again for applications to come in. We are well funded to pay for a portion of those internships that to help bring the renewable energy field to especially students and or others that are in the low to moderate income areas so that they too can participate in the energy revolution. The deadline right now is March 31, but we do need volunteers. Oops. I think, Michael, that was you. We do need volunteers to help review the applications, to help with interact with the solar and other companies that are hiring these interns so that we get their job postings, so that we have an understanding of what each side expects out of the internship, and so that everybody can have a terrific experience, which we have had. As we told you in January, one of the interns from last year actually obtained a full-time employment with a solar company. So we are bringing benefit to the community. It's beginning to show up. The community project we did last year with the city of Dallas for the development of a framework of resiliency hubs was incredibly important for the community, especially after what we went through in February of last year. And that is another great committee to join to help solicit and select and participate in a new community project for 2022. So with that being said, let's turn to the next portion of our agenda, which is announcements by members. Do any members have any announcements they wish to make? Raise your hand, you'll be recognized, or unmute yourself and speak up.
Hi, this is Molly. I'd like to make an announcement about the Climate Reality Project and things that are coming up there. The meeting date, as you know, most of you know, was changed to the Saturday after this meeting. It's been in the afternoons, but people wanted it to be in the morning, thinking there might be more participation. So it will, starting this next week, the monthly meetings will be at 10 a.m. rather than in the afternoon. So I think that James said he was going to post something in the chat about how to virtually attend that meeting. This next meeting will be focused on chapter announcements and updates, and as well as some in-depth information about some of the working groups. And the other main thing to mention is that there's going to be a special meeting on solar on commercial buildings. Since nearly 2/3 of greenhouse gas emissions in the city of Dallas come from the building and energy sectors, it's really important that we try to get some of these big box stores, rooftops, to have solar on them, because there's enough solar potential there, equivalent to around 8 million American homes. And the climate leader, Michael Martin, who you're familiar with through this group as well, will be leading the discussion about how to take action to accelerate the widespread deployment there of on-site solar power for the commercial property owners. So that's going to be that's going to be on February 22nd at 5:30 on Zoom. So hopefully we can get that in the chat as well, and perhaps send out on the community conversation emails as well. And I just want to mention one more thing is, as part of the greening schools, greening Dallas ISD in particular project, there's a big focus right now on trying to get the city of Dallas and other school districts in the North Central Texas area to use some TCEQ funds that are now available to purchase electric school buses. And some of y'all are already familiar with that effort and the need to get more input to the trustees. So I'll be sending an email out later about how people might be able to help in that effort. I think that's it. Thank you very much.
Thank you, Molly. Anybody else? Any other member announcements? Okay.
Rosa, do you hear me okay?
There you are. No, I couldn't hear you. Go ahead.
No, I don't have any announcements except for the fact that if you know of any young people that are attending junior college or the universities, if they are interested in the internship program, please send them our way, because we are wanting to help that program be implemented and to support the renewables industry in the Dallas-Fort Worth Metroplex.
Thank you, Michael. Any guests who are not members have any announcements they wish to make? Okay, hearing none. Molly's already.
Tracy Wallace raised her hand.
Tracy, I didn't see your hand raised. I'm sorry. Go ahead.
That's okay. I just wanted everybody who has supported Green Careers Dallas to know that we have signed an MOU with Restorative Farms, and since our other location fell apart, that is where we're going to build what will be a shaded outdoor classroom structure for both Restorative Farms and us, but also we will do our training on that rooftop. So we will send, once it's completed, we're going to have a little open house, and we'll send an invitation via NTREG, and we'd love for people to come see our new place.
I'm sure we will. Tracy, we might try to crash it for a meeting or two.
That would be fun.
Okay, anybody else? Please raise your hand or unmute yourself. Okay, I just checked everybody. I don't see anybody else hand raised. Michael, let's see. Who was gonna make the announcement on the special meeting on the solar and commercial rooftops? Is that you, James?
Well, actually, Molly already presented
Okay.
that. And let me go back to screen. I believe James will put that link in the chat, but it's also on the agenda as presented here, that special meeting and the link. If you do a screenshot of this, you'll be able to access it from that as well.
Okay, terrific. Michael,
I'm going to stop sharing my screen to go to
Yes.
the PowerPoint presentation.
Let me turn it over to you. And Tony.
Okay. Whoops. Bear with me one moment while I bring up the screen. Well, can everyone see this screen now?
Yes.
Okay, thank you very much.
Yes.
I apologize for that. Technology is always a work in progress.
I have a question before we get started.
Yes, hi, Tony.
There's a panel in the middle of this screen that says this meeting is being recorded. Can you minimize that?
I do not see that.
You do not see that.
Can you just,
Tony, I think if you accept or say agree or got it or something like that, it'll
Oh,
disappear.
there we go.
Yeah.
Sorry about that.
More technological challenges.
Yes.
So, Tony, if you're talking, it will show your video or your so that hopefully you'll be the only one that's presented there besides me.
Yes, you
But
can-
let me
you all
introduce
can hear-
Tony.
You all can hear
We're
me
very,
okay, right?
there you go.
Yeah.
I would like to introduce Tony Robinson. He's been associated with the North Texas Renewable Energy Group for a long time. And he's done several presentations, but his expertise is in sustainable building and really focused on building envelope. And that's what he wants to do is a technical presentation on building envelopes and how it controls energy equation. But you know, Tony, he is a local designer builder. His company is Axis Building Consultants, which was established in 1989. And his role in the community has been to provide assessment, education, and implementation for resource efficiency and high performance buildings. He's also an adjunct professor in environmental sustainability at Southern Methodist University. He's a board member, he was a board member or is a board member on the Environment and Sustainability Task Force at Dallas, recently finished. And he is an author of a textbook that is used throughout universities and architectural schools called High Performance Buildings, a Guide for Owners and Managers. So Tony, I'm going to turn it over to you. Looking forward to your presentation.
Very good. Thank you, Michael, and thank you to everyone who's attending this morning. It's an honor and a privilege to present here to NTREG again, and I appreciate the opportunity. Just a little background on this presentation before we get started. As many of you know, I've been a member of the Association of Energy Engineers for many years. In 2014, I published this book. See if I can get it in here, into the frame.
There you go.
There you go. High Performance Buildings, a Guide for Owners and Managers. And it's a 400-page technical book, and it's a textbook, and it's kind of expensive, so it's not very accessible, unfortunately. So about 3 years ago, I went to the publisher, and chapter 7 is on the envelope. And for 40 plus years in the construction industry, my focus has been on the building envelope and how to make it more energy efficient. So I asked them if I could take that chapter out of the book and do something else with it, and they agreed to that. I realized that I wasn't going to write a whole nother book on it. So my goal was to create a monograph or something much smaller, edit it down so it was more accessible. So I wrote a 30-page technical paper, which AEE accepted, and I presented that paper in December of 2020 at their virtual conference. And that's what this presentation is based on. Inside Out, why the building envelope controls the energy equation. Next slide, please. Michael?
Michael?
It's like we lost Michael temporarily.
Guess we lost Michael there, yeah.
Dan, do you have the presentation as well?
I have it, but my internet connection is unstable this morning.
I hear there's a storm
James?
coming in the west.
James, do you have it?
Yes.
Can you resume it while Michael comes back? Please.
There we go. Perfect. Inside Out, why the building envelope controls the energy equation. Could you go to the next slide, please? Okay. The building envelope is a thermodynamic system which interacts with the occupants of the building and the environment around it in a great variety of ways, and it's very complicated, actually. And not enough attention is paid, in my opinion, in this country to the design, the engineering, and the performance of the building envelope, which is critical to the energy efficiency of the entire project. So this graphic is meant to show various ways: solar radiation entering the building, heat entering the building, heat leaving the building, diffused radiation, sound, objects in the area like trees, mechanical and electrical systems, etc. Next slide, please. So there are principal functions that the building envelope performs. It manages heat flows between the internal and the external environment. It mitigates sound transmission. It emits and controls daylight. And of course, it diverts and controls flows of air and water. Next slide. So the building envelope controls the energy equation by mediating all energy transfers between the internal and the external environment. And it does this based on regional and local climatic conditions, the mediation of the envelope, given its physical properties of the materials it's composed of, and the activities of the occupants inside the building. Next slide, please. So we're all, of course, familiar with the greenhouse effect on planet Earth. The atmosphere is actually like an envelope, and the building envelope has similar properties, principles to the atmosphere. And so when we look at how things operate in the greenhouse effect with greenhouse gases and the atmosphere of the Earth, we can take some of those principles, some of those ideas, and apply them to the building envelope as well. Next slide, please. In effect, the building envelope creates a greenhouse effect inside the building. On the left is a greenhouse built in the 19th century in France. On the right is one of Sullivan's office buildings in Chicago in the early 20th century that has punched openings with glass. And so the building actually is a type of greenhouse. Next slide, please. So let's talk about various external conditions that affect and bear on the building envelope and how it performs. On the left, these are not particularly updated maps, but on the left is a map showing solar radiation intensity across the surface of the Earth, given in watts per square meter. On the right is something published on a regular basis by the National Renewable Energy Laboratory, the National Solar Radiation Database from various stations around the country, showing the intensity of solar radiation. So we can obviously use these kinds of materials to determine what's available to us for solar energy. Next slide. More regional climatic conditions on the west. Those of you who are in the wind energy part of the business, the NREL also publishes maps showing average wind speeds in various regions of the United States. On the right is a precipitation map of the state of Texas. So we can also detect, measure, and record average rainfall in various areas where we want to put our building. Next slide. We also have what are called microclimatic and local features. These are, the way I define this, is things that are within a quarter of a mile of the building. You know, this could be vegetation, bodies of water, trees, other buildings, etc. We also have things which affect the building in the immediate area. On the left is something called a windrows, which could show us average wind speeds for a particular location. On the right, of course, is a solar path diagram showing us solar radiation available at various solar profile angles for the building. Next slide, please. So the energy equation, how does this work when it comes to basically evaluating the design and functionality of a building envelope? Well, we start with climate, things we've already discussed like radiation, temperature, wind speed, precipitation, etc. We go to the design phase. We decide how we want to orient this building, north, south, east, and west. We discuss glazing, wall types, roof types, etc., going clockwise. Then we consider materials and their various properties, absorptance, conductivity, resistance, etc. And then finally, of course, we have to examine the usage profile of the building. What's the occupant behavior going to be? What are the energy requirements? How do we monitor it? Next slide, please. So principles of energy transfers and the building envelope. First of all, we're looking at the rate and the intensity of the flows. This is flows of all the things we've already discussed: sun, wind, rain, etc. And those are all measurable from regional and microclimatic data. The orientation of the envelope, what compass orientation is it going to have? That's from our design analysis. The performance characteristics of the materials in the envelope. These are required from lab testing, obviously furnished by manufacturers, but they're also determined by on-site performance. We found in over decades of doing testing and evaluation that the way materials perform on-site is not always the way they say they're going to perform from lab testing results. And a lot of that, of course, is environmental and local factors. And then we also have the building usage. We get that from occupancy profiles and utility data. Next slide, please. So we have to talk about material properties in the envelope. High performance envelopes ideally engineer and orient the component systems of the envelope to optimize energy flows to the advantage of the building and the occupants. And we have 6 basic principles or properties: absorptance, the ability of a material to absorb radiation; conductivity, that's the thermal conductance of a material; resistance, where we get R value, overall resistance of a material, to thermal conductance; and U value is another value, and that's used to rate the overall resistance of an assembly of materials; emissivity, the ability of a material to emit energy by radiation; reflectance, that's the percentage of incident radiation reflected by a material; and transmittance, the percentage of incident radiation which is transmitted through a material, in particular, for example, glazing. Next slide, please. Energy usage. So we get a number of formulas from various authorities which allow us to establish benchmarks, averages, targets, things like that in terms of energy usage. The first, the energy intensity of a building, that comes from the Energy Information Administration. That is simply the energy consumption per unit area. For example, kilowatt hours per square foot. The next, energy use intensity, comes from the International Green Conservation Code, EUI, which is equal to the total annual energy projected to be consumed on the site. That would include renewable energy, wind, solar, etc., divided by the building gross square footage. That gives us the energy use intensity. From those formulae, since I had spent so much time on the building envelope, I thought it would be perhaps useful to derive some other formulae which we could use in the design of the envelope and also in the design and application of renewable energy to help us get ratings or coefficients or things like that to evaluate on envelopes before they're designed and built. So one I generated was the energy production of an envelope, EPE. This would be the energy which can be generated, collected, and converted per unit area of an envelope. For example, kilowatt hours per square foot of wall or roof. We would also then have another benchmark or measurement, the conversion efficiency of the envelope, CEE. That would be the ratio of the energy absorbed to the energy generated per unit area. So for example, you could have a 200,000 square foot warehouse in Arizona, which could generate, obviously, electricity from solar panels on the roof. And you could compare that with the same 200,000 square foot warehouse, the same orientation in Pittsburgh, Pennsylvania. And then you could get a number there which reflects local conditions and affects this conversion efficiency. And finally, the energy generation coefficient of the envelope, which I call EGCE. That would be the energy production of an envelope divided by the energy intensity of a building. This would give you a ratio, like a coefficient of performance. This would be the ratio of the energy potentially generated by the envelope per unit area divided by the energy consumption per unit area. This would be a number between 0 and 1. 1 would represent an envelope which produces as much energy as is used, consumed by the building per unit area. And that way you could have like a coefficient of performance for a building envelope, the same way you do for air conditioning equipment or other things of that nature. Next slide, please. So the building envelope is a thermodynamic system which regulates energy transfers of heat, light, and sound. Next slide, please. So let's talk about heat when it comes to roofs. Most standard roof systems are similar to this, and they depend on different layers of materials to resist and reflect heat transfers, both in and out of the building. Next slide, please. Then you might have something like a green roof, which operates differently than a standard roof. It resists heat transfer, but it also absorbs heat and converts it, in this case, into vegetation, while at the same time, it is resisting heat flows inside and out. Next slide, please. This here is one of the most interesting buildings that I visited here in the United States, the Greenpoint Design and Manufacturing Center in Brooklyn, New York. I was there, 7 or 8 years ago. And in this case, they've taken an old warehouse building and converted it. What they do is they lease spaces to boutique manufacturers and tradespeople. It's a very interesting concept. And they get these built, they're a nonprofit commercial real estate developer that works for the city of New York. And they acquire and repurpose abandoned buildings. And then through, grants and loans and other things like that with the city of New York, the state of New York, they're able to lease these spaces to small business people who would otherwise be unable to afford this kind of thing, in the 5 boroughs there. But in any case, on the roof of this building, they have managed to cover almost the entire roof. About 50% of it is solar panels, which I was told back then were producing roughly 50% of the electricity required in the building. Also is an operable commercial greenhouse system on the roof where they grow herbs and plants and vegetables, which are sold locally in this neighborhood. So this is a great example of a roof which is managing heat flow through reflection, absorption, and collection all at the same time. Next slide, please. So when it comes to walls, they're kind of similar to roofs. You're generally dealing with resistance and reflection. You build up various materials and component wall systems that retard, reflect, try to slow down the transfer of heat through the layers. Next slide, please. Another way that's been getting done for the last 20, 25 years using the principles of resistance and reflection, and also walls that are a bit thicker, a bit more massive than your standard 2x4 stud wall. Of course, the ICF wall on the left, which has become fairly popular. We call these composite wall systems. ICF is the insulated concrete form. On the right is the SIP panel, structural insulated panel with foam. Both of these are very, very tight, very thermally efficient systems. Next slide, please. There we are. Then, of course, you have green wall, which is not so common, but is also highly effective. You can create grids or cable systems that vines or other types of plants can grow on. If you have a south-facing wall, of course, you could have deciduous greenery, which shades the inside of the building in the hot months, and then the leaves fall off, and in the wintertime allows beneficial sunlight and solar radiation in there. The building on the left, I believe, is in Europe, and the one on the right is the San Francisco Museum of Modern Art. That is more aesthetic on the right than it is functional because of where it's located. Next slide, please. Then we have some walls which do all three things at the same time. They reflect, they absorb, and they collect. On the left is a fully integrated, it's called BIPV, Building Integrated Photovoltaics. The photovoltaic panels are actually part of the curtain wall system. They're in the system. There are, of course, advantages and disadvantages to this. And this application hasn't been done a lot because it's expensive. They need to get the cost down. And there are a few logistical problems as well. That building on the left, I believe, is in Germany. The one on the right is in Spain. That's where actually they still call it building integrated photovoltaics, but that system is on an offset from the exterior wall. So it's not part of the wall, and you don't have direct transfer coming through the system as you would on the left, since that is a glazed curtain wall. Next slide, please. Floors are pretty simple when it comes to thermal transition. You're talking about resistance, which means building up layers typically of, various types of expanded polystyrene foams or polyurethane foam panels, things like that, to isolate the masonry from the ground and slow down transfer that way. Next slide, please. Light. Light is one of the most important parts of the building envelope, daylighting. I spent a very large percentage of my career working on daylighting, skylighting, glazing, curtain walls, etc. When daylighting is designed properly, it performs a lot of essential functions. It provides task lighting in the same, not in the same way, but in a similar way that electrical lighting does. It improves productivity and increases wellness. These are sometimes hard to measure, but it absolutely is a fact that natural light improves productivity and increases people's wellness. Studies have been done on this. I would draw your attention to a building built in the last, I think, 5 or 6 years. It's a building at the UT Southwestern campus. And it's a fantastic building. It's a hospital building. And for years, hospitals didn't understand, for whatever reasons, that natural light, daylight, is key to people getting well faster. And that particular building, that's the William P. Clements building at UT Southwestern. Go in there sometime. It's a fantastically well-designed building. There's natural light everywhere, in the hallways, in the patient rooms, in the offices, in the lobby, in the eating areas. And it is so pleasant to be in there when, of course, you know, you may be visiting someone, a family member who has a serious illness, but all of that really contributes to everybody's feeling of well-being. Daylighting also minimizes electric lighting costs. Even in the era of LED lighting, it is still going to have an impact on that. In some cases, in northern climates, it can reduce. It can reduce cooling costs sometimes during the cooling season, based on the fact that you are not using electric lighting, which generates heat, and you're using daylighting, which is properly controlled. Next slide, please. So daylighting has been used from an architectural standpoint for thousands of years, of course. One famous example is the Galleria in Milan, built in 1865, with that very dramatic skylighting up there, and provides fantastic light for the inside of the Galleria, and is high enough up to where glare and heat gain are minimal problems. Another great example is Bell Labs in New Jersey, designed and built about, I believe Eros Saarinen was the architect there, built in 1967. You see the atrium there with the offices on the cantilevered decks all around. All of that's glass, all those railings, that's a north-facing wall. It also has diffused skylighting. So you have great natural light there in a laboratory setting as well. Next slide, please. There are a lot of different ways to do daylighting and do it effectively and efficiently. On the upper diagrams, you can see the use of a light shelf and a clear story above it. So you get reflected light into the room rather than direct solar radiation. And then in the wintertime, you get more direct sun solar. Various types. You've got clear story, monitor, sawtooth, skylight as architectural approaches to admitting daylighting. Next slide, please. Glazing. I spent a good part of my career dealing with glazing, both vertical and overhead, and ways to control it and shade it, et cetera. On the left is a standard piece of single heat absorbing glass. We can look at the ratings on it, the U factor a bit over 1, the solar heat gain coefficient, 73% of the solar heat is transmitted through the glass. The visible transmission is 68% of visible transmission. They go over to the right glass, more characteristic of everything we have today. That is this is what's commonly referred to now as low emissivity glass. It's an insulated glass unit that has coatings on several different surfaces, which are done with vapor deposition. And this particular piece of glass I believe, is PPG's Solar Band 60 insulated glass, which is getting close to the theoretical limits of what they can do with the materials at this point. You can see that the U factor is less than half of what it is on the left. The solar heat gain coefficient is about a third less, but the visible transmission stays right around the same. So that has not been affected. Next slide, please. Inevitably, you have to, whenever you're doing daylighting, you're going to have to do some kind of shading because even if you have PPG Solar Band 60 in your curtain wall or your window, you're still going to get, when you have direct solar radiation on the glass, you're going to have transfer through that glass. You're going to have glare. So you still have to control it. The diagram on the left shows you different ways to do that and how that works physically from the standpoint of direct transmission and reflected light. On the right shows you how the effectiveness of exterior shading versus interior shading. Exterior shading, and I sold many of those products for years, is dramatically more effective than interior shading because you have simply physically stopped the direct transmission before it reaches the surface of the glass. Once it reaches the surface of the glass, it's going to go inside. So you can control glare, obviously, very effectively from a shade or a louver or whatever inside the window, but you're not going to control heat gain because it's already passed through the glass. Next slide, please. So here are various, basic ways that get used to do shading when shading is an architectural feature of the building on the exterior of the building. And there's a lot of resistance to this in this country. I'm not sure exactly what that's about. It could be an aesthetic issue that, people don't want to design exterior shades. They can be costly. They don't like the way they look. They require maintenance, et cetera. They have a very different approach to this in Western Europe. They use exterior shading all the time over there. Next slide, please. So here's some basic examples of, exterior shading systems. The two on the right are both operable. Both of those are in Europe. I think that's Germany at the top, and the bottom is, I believe, France. But those systems are all operable. They're motorized, so the energy management system can actually control those louvers, those blinds, according to what the exposure is at a given time of day from solar radiation. The one on the left is actually a fixed exterior shade system, which is on the building we're going to see in the next slide, please. So the Lawrence Berkeley National Laboratory at UC Berkeley does a lot of the, work on glazing, solar radiation, et cetera, and they have for decades. And so for, many years, people kind of thought, well, daylighting, shading, it doesn't really make that much difference. We'll just pump more air conditioning into the building. It actually makes a huge difference, as LBNL proved in this case study on Renzo Piano's building for the New York Times in New York. This goes back to 2006. So LBNL created what they call a Radiance Model. It's a 3D model of the building and all of its surroundings and the solar radiation profiles 24/7, 365, whatever it happens to be. After they did all this analysis and they also implemented all of these recommendations, they found 40% energy reductions by doing good design on daylighting and external shading. So it does work. Next slide, please. Sound. Often we don't think of sound as maybe a critical factor, but it really is, and even more so now. The outside world is a lot noisier now than it used to be, and also the inside of the building is noisier. We have more mechanical equipment, we have more, various machines. Things make a lot of noise now, both inside and outside the building. So we have to have effective techniques for controlling, sound as a form of energy also. That transfer of sound between the inside and the outside. And also once it gets inside, what do you do? So a standard rating is called the sound transmission coefficient. And what you're trying to do is create a situation where that number is as high as possible. You can't usually, eliminate sound waves or transfer sound. What you want to do is you want to get it down to a level where it's barely noticeable or it doesn't distract you or irritate you. So you can see down on the right there, various sources for sound waves and also what it does once it gets inside the envelope. Once sound waves enter, believe it or not, enter a wall, they can also then go up and travel through a ceiling and come down into the room. They can also do the same thing through the floor. Next slide, please. One way of what you're trying to do with sound is increase transmission loss. You want to somehow short circuit transmission and thereby increase the SDC value. There's basically two ways to do that. One is to change materials. And so that changes the way the sound waves are transmitted through the material. On the left is a piece of laminated glass. So you've got a layer of glass, a PVB inner layer, which is essentially a polymer, and then another layer of glass. So you are interrupting the sound wave as it comes through the material, and that helps raise the SDC value. You can also change materials and you can decouple them. On the right is an example of a double stud wall, where these stud walls are actually separate from one another. We've done this on a few occasions. It's also highly effective. Next slide, please. So one of the things I wanted to do in the book on the envelope and also in this monograph in this paper is get down to the basic principles, forms, and functions of envelopes. So our discussion is not relying on specific materials. It's relying on basic principles for how it works physically. So we can then apply those in various situations. The first type of envelope generally used by human beings was what I'll call heavy mass. And that is going to be a barrier. What you're trying to do with a heavy mass envelope, a very thick envelope, is you're trying to retard the transmission of heat through the envelope. And in the same way, you're maybe retaining what's already inside the building instead of losing it. The section you're seeing on the left there is a section of the Pantheon in Rome. I was in Rome once in the month of July. It was very hot. It was probably 95 degrees outside. And we went inside the Pantheon, and the Pantheon is not an enclosed building. The arcade that goes around the building is open. And there's an oculus at the top of the dome, which is open. But I'm going to say that inside the Pantheon, it was probably 70 degrees. It was about 25 degrees cooler inside this building. It was not enclosed, and of course, had no mechanical systems operating. So what the ancients understood is that a heavy mass, a thick envelope, can be very effective. We don't do that much anymore, but that was something they already knew. We then, over a period of thousands of years, transmitted to what I call a light mass envelope. That's one where it's much thinner, the materials are lighter, and you're depending on other principles. Not just retard and retain, but you're also going to reject and remove, because then we introduce mechanical systems into the equation. to remove unwanted heat or to add wanted heat, of course. Now, when we get to high performance buildings, which is what we should be doing now all the time, the envelope is going to have three functions. It's going to be a barrier. It's going to act like a membrane, and it's also going to be a collector. So it's going to depend on three principles: retard and retain, reject and remove, and absorb and translate. This could be a thick or a thin envelope, as we'll see in some examples coming up. Next slide, please. So what we did was profile some basic climate types. You know, it's not quite this simple, but we wanted to have 4 basic examples of buildings in different climate types with very efficient envelopes and kind of how they work. So the famous Earthship in Taos, New Mexico. These buildings were designed and engineered by Michael Reynolds, the architect of biotecture design. You can see there the basic layout, design of these buildings and how they work. So you have a heavy mass envelope. You have passive solar. It's a high performance building. It's hybrid materials. It's net zero energy and is material reuse. You see rammed earth there on the hillside of the building. My former engineering professor at the University of North Texas, John Dobson, and his wife, Joan, after he retired more than 20 years ago, moved out to Taos, bought land on the Rio Grande Gorge, and he, with local people helping him, he built one of these houses himself. The walls are made with tires, rammed earth. And there's 2 levels to the building. He and his wife live on the upper level. On the lower level are 2 apartments. And it's like it's not really an Airbnb. It's more like an inn. It's called Dobson Ranch Inn. And I stayed in the building once for several days. And they have no heating and air conditioning in that building. And they don't need it. It's extremely comfortable. Next slide, please. Here's a temperate climate. For example, San Francisco. High performance and green buildings are a lot easier to design for out there because of their temperate climate. This on 11th Street in San Francisco. This one's interesting because it's an adaptive reuse of an existing building, and they converted it into a restaurant, industrial, commercial. It's a light mass building. It has the original footprint and framing, but they installed a green roof. They put a perforated screen, shade screen on it, and they also have photovoltaic panels. A very interesting reuse on that building. Next slide, please. Here's an interesting building, the John W. Ulver Transit Center in Greenfield, Massachusetts. It's new construction. It's public architecture. That's a hot, cold, and humid climate. It's light mass. It has a copper panels and lighting screens. It has solar photovoltaics. It's also a net zero energy building. It has a solar wall that's absorbing. And it also has some interesting, it has geothermal wells, and it has a wood pellet boiler on site, in which they create heat from that, kind of district power, and pipe that to the building. Next slide, please. They're a hot and humid climate. Gainesville, Florida. Michael Fladmark knows about this climate. Rinker Hall at the University of Florida, I believe it is. It's new construction. It's institutional. Very interesting design on this building. You can see how they've made daylighting a very important function. They have shade walls. They have solar screens. They have skylights with high performance glazing. They have rainwater collection and a very interesting, fully functional building from the high performance standpoint. Next slide, please. So the high performance building envelope ideally efficiently controls the energy equation, and it reduces the overall requirements for mechanical and electrical equipment right from the get-go. That's the important thing. It's not just important for, standard mechanical systems that are grid fed. It's also extremely important for renewable energy design, because obviously we want to reduce the requirements for solar photovoltaics, wind power, et cetera, so we can get the overall cost of the building down. And that's what having a primary focus on the building envelope does. It gets the overall life cycle cost of the building down, because if the envelope is designed properly, it doesn't degrade. It performs the same way it was originally designed, day in and day out. Is not outmoded by things like utility costs or other technologies may help the building produce power more efficiently, but the building itself is operating and being maintained efficiently right from the beginning. Thank you.
Hey, thank you, Tony. I would like to take, James, if you don't mind, stop sharing your screen, and then I can pull back up because thank you. So what we want to do here in closing is we have some questions, and Rosa, if you can start asking Tony some of the questions, that would be great, that came through the chat. And then anyone else who has a question can ask Tony directly, in regards to his presentation or something that you think about that, he would be able to provide an answer for. So
I just wanted to add one thing before the questions. NTREG is going to post.
Well, this is what I'm trying to find. I'm trying to pull that up, Tony.
Yeah, NTREG is going to post a copy of the technical paper. It's about 30 pages long that this presentation is based on. So you can refer to it if you want to.
Okay, Tony, thank you for that presentation. Truly enjoyed it. Always like learning things. So thank you so much. We have a question for Mark Whitty. He says, what do you think about the commercial viability of a new highly reflective paint? Reflects 98% plus of solar radiation that was developed by Purdue University.
Yes, increasing reflectivity is extremely important. It doesn't entirely eliminate the transfer of energy through the envelope. You just have to keep that in mind, because there's different kinds of transfer. Reflectivity has to do with transmittance. You're also going to have transmission through the envelope through other effects like convection. So that's a very important piece of the puzzle, and it's great. It's like putting highly reflective roof coatings on a flat roof helps reflect and retard transmission.
Okay, see.
Does that make sense?
Rosa, you had a question regarding Adobe. Do you have experience working with Adobe?
Yeah. So Tony, have you had any experience working with Adobe, and in what circumstances, and how do you find it as a building material?
I personally have never built with Adobe. I have to admit that, although I lived in Arizona for 3 years. So we worked on buildings we worked on traditional buildings that were built out of Adobe. And, that's a thick wall envelope, and it's highly effective. I mean, we worked on some buildings in South Tucson that were built in the early 1900s. It could be 110 degrees outside. So these Adobe walls were probably about 18 inches to 24 inches thick. And, it could be, of course, it's very dry out there, but it could be 110 degrees outside and it would be a comfortable 75 inside the building. So it's very effective, no question about it. Kind of like that principle in the Earthships, very similar principle there in Taos, but what they do is they take tires, they take scrap tires, and then they ram earth inside the tires. And then they actually plaster adobe or stucco on either side of that. So you have this very massive wall that resists energy transfer.
I saw a question here from Mellon, and I'm trying to get to it.
Yeah, his question dealt with local SIPs. Are there any local manufacturers for SIP paneling? And then also the follow-on for that question was, who are the leading manufacturers for SIPs?
I'm not the best person to ask about that because I'm not a user of SIPs, although I accept it's, I've been involved with a few projects where SIPs got used. There was a long-standing company out in Arlington that manufactures SIPs. But who the best person to ask about SIPs is Paul Westbrook, because his house is built out of SIPs. I don't know that he knows who the current suppliers are, but
following up on building codes, Larry Howe is wondering how the warming climate is being taken into account, given that the data we have, the historical data, is probably not as instructive with the way climate is changing.
yeah, that's true. And that is a difficult factor to integrate into a building code. Any of you have had any experience dealing with building codes, whether it's because you're a builder or you're working on a committee or something like that to get them changed or to get them more efficient. Building codes kind of lag behind, what's actually happening in the marketplace and also in the climate. Because of what's happening in the climate, that in my mind makes it even more important to design, engineer, and build envelopes that are high performance right from the start. Because without misusing the word insulate, but it insulates you from more extreme temperatures to have a better performing envelope.
There's another question. I think it's somewhat related to mine, but the question was posed to get your thoughts on low cost in high performance materials such as hemp strawcrete or styrocrete as wall fill and insulation. Am I misunderstanding the question? It's unassigned, so I don't know who to assign that question to.
All right, sorry, that's Phil. Yeah, that question. Styrocrete, you use aircrete and mix in, instead of gravel, you use scrap styrofoam. It's not necessarily a real structural item, but it's good wall fill. Same with a hempcrete. Hempcrete's kind of the, Tommy Chong thing, but you can use straw the same way. They both bind on the silicone.
Yeah, I think one of the most important things with insulation materials is whether it's hygroscopic, which means does it absorb moisture in any way? Because if it does, the moisture has to be released. So on something like hemp straw, or I don't know what the styrofoam material you're referring to, although I have seen some concrete mixes put together with micro beads or styrofoam beads that makes the material lighter and more resistant to energy transfer. Is that what you were talking about with the concrete product?
Yeah. Normally it's a cement, sand, gravel mix. In this case, you the gravel and you put styrofoam, ground up styrofoam in its place.
I've seen a number of those materials. I don't know. See, for example, if you're going to use any kind of material like that, in order to be integrated into the building process, unless you're out in the county and you can do whatever you want, it has to meet, certain standards like ASTM standards or things like that. It has to be tested. So some of those materials which I've seen look interesting, but they actually haven't been tested the way most building materials have to be. And so introduction to the building code is difficult or impossible if you don't have that as a background on the material. But if you're asking about straw, for example, people used to mix straw with Adobe. Made it easier and lighter. And I think the straw probably had some insulating properties as well when it was
So that has reference clear back to, Egyptian times, as it were, Book of Genesis. That was, straw for the brick making. So
yeah, absolutely.
So it sounds like what you're saying, that it's too early because it hasn't been tested or established standards yet to use as a general purpose product. Would that be a quick summary?
Right, exactly. The Pharaoh Tutankhamun did not have a building code or any building inspectors. He just kind of did it the way he wanted to.
Understood.
But on that vein, the ancients, I'm referring to a whole lot of people here, going back thousands of years, they already knew what they were doing with buildings. They didn't have any high performance materials, but they knew how to build buildings that are going to stay there for a long time and were very energy efficient. It's just, it's not cost efficient to build heavy mass buildings now. That's one of the problems. Unless you're talking about the earthships. Those are actually fairly cost effective because all of those are generally built into the side of the hill there at the Rio Grande Gorge. And they're facing west. So they have this huge earth mass underneath them and behind them, which is helping to insulate the building right there.
Rob was asking what is the single best thing to do to make an older, typical Texas ranch house more energy efficient? The top thing to do.
Yeah, well, the low-hanging fruit, which would mean the least expensive things to do, number one, of course, is to re-insulate the attic, but you also need to check all the ductwork because it's estimated that we're losing about 30% of the air-conditioned air through ducts, joints, all over this country. So that's a huge waste reduction right there would be to go in and, check all the joints, both, where the ducts join inside the attic, where they join to the HVAC unit, et cetera, et cetera. And then, of course, re-insulate the attic by, in a standard, ranch style house, you're not going to go in and try to re-foam everything. So at that point, it's already built. But yeah, go into the attic and, put blown in insulation up there to R40. And that'll help a great deal. You can also do windows, of course, but, window replacement's kind of expensive and it doesn't have a good, return on investment like insulation does.
Jeff wants to know how is the soil he found in parts of north central Texas dealt with when using insulation under the foundation?
We don't use insulation under foundations very often here in North Texas. And that's because there's just not a whole lot of transfer. But, one of the things we do every time we have a project is we always do geotechnical engineering. So they come out and drill down to 25 feet. So we know what's going on under there in the soil. And soil profiles can vary a lot. They can vary a lot from one end of a block to the other end of a block. So once in a while, you'll see I've seen people put insulation board on the outside of a slab or a beam, and that helps, retard transfer from the side. But it actually doesn't get done very often here in North Texas because we don't have, well, except for February of 2020, 21, we don't have extremes of cold here that last for very long. So.
Jimmy Hosh, his question is to please comment on the methods and costs of dealing with a temporal mismatch between the time that PV energy is generated and the time when a net zero energy building requires the energy.
Between the time that PV energy is generated?
Yes, and the time when a net zero energy building requires the energy. Jimmy, did I mess up your question?
You mean?
No.
Okay.
Here's the question.
Okay.
At night, you're not going to get any PV energy at all, and yet you still need some.
Right.
In the winter, it's cloudy, it's colder than you know what, and you need energy.
Yep.
And you've generated plenty of energy, more than enough throughout the year. The trouble is, I need it now, not in July.
Right.
How do I get it from July to here now? And how much does it cost?
I really think that unless you're off grid, hybrid systems are going to kind of be our transition approach. We're going to be grid connected with solar. Battery storage obviously mitigates some of that problem that you're talking about. The battery storage is still rather expensive. So we're going to have to get the cost of that down a lot because that solves some of your problem of, on demand. But when the PV system can't produce the electricity that you need, there's two things you can do about that. One is you still have to be grid connected so you can get the power when you need it. The other is if you design your high performance building with an extremely efficient envelope, you are going to get the requirements for electricity way, way down so that when you have a demand situation, it's much easier to meet it.
Okay, I understand that. But let's go back to the assumption that I will be grid tied, which I am.
Yep.
The grid has got to store that energy too, because I've been pumping that energy into the grid, all year long. And then comes February and it's cloudy for 2 weeks and I need energy and the grid's got to supply it. Where does it come from? Right now it's coming from fossil fuels. And we all think that's not a good idea. And the grid is going to have to supply all of Texas, all of the energy it needs for 2 weeks with no PV input.
Well, yeah, let me give another more general answer to your question. One of the most important focuses of my talks about energy is on waste reduction. We are extraordinarily wasteful with the energy that we produce in this country. The Lawrence Livermore National Laboratory produces a flow chart, like a spaghetti chart, every year. And we are wasting or losing it to inefficiencies more than 60% of the energy we produce. So a good way to help out on the grid is not for us to go out and spend a lot of money on existing buildings. We can do that if we want. A better way to tackle that problem right away is, like it or not, for us to change our habits, the way we consume energy, because unknowingly we're extremely wasteful, and that's across the board. That's energy, that's water, that's food, that's materials. So if we want to take pressure off the grid, which we do have to do, and have the power, have more power when we need it, when there are emergency situations, we have to, waste reduction is job number one, in my opinion.
Thank you.
Okay, Tony, James wants to know if you recommend that local cities adopt the 2021 International Green Construction Code?
I cannot say, I would say in general, yes. I have not read the most current version of the IGCC. I refer to it in my book, but my book was published, 2014. I would say yes. I think it's basically a code, a good code, and it's balanced. Yes.
Again, another question about your thoughts on using conventional solar PV panels as a roof, not on the roof, but as the roof material itself.
I think that's an application of building integrated photovoltaics that I talked a little bit about. That was on wall systems. I think there's a couple of issues there that I don't know if they've resolved yet. Solar panels get hot, and if they're not isolated from the roof deck somehow, then they're going to transfer heat through the deck into the attic or into the building. So I'm not sure. Yeah, I haven't actually looked into that recently. Tesla was working on a product which was roof tiles. It's a good idea, but so far it's still very expensive on a per square foot basis. And you have this issue with, isolating the heat transfer from those tiles or those panels, excuse me, into the building.
Did that answer your question? There was a follow-up to it
I
about whether.
want to follow up on that if you don't
Okay.
mind. Rosa.
Go ahead,
Yeah.
Michael.
So I'd just like to direct everyone to a recent YouTube video that I came across that deals specifically with this. And this is a European application, but it was by Victron, their systems, but they actually did a roof, I believe it was in the UK, where the solar panels themselves were the roof membrane. And of course, it's a lot more expensive when you do that because you have to also deal with the weather sealing, keep out water, and they incorporated a drain system for their rainwater harvesting and everything. So yes, it's being done, but it's very expensive. So it's not really what we would call a practical solution, but if you have the money to do it and that's what you want to do, I mean, of course, it's successful. But Victron is a manufacturer out of the Netherlands. They've been around for a long time. They originally started with marine and mobile applications, and they've become more and more in the residential and commercial applications now.
Yep.
But, and I'll step back.
You want to take the next
you,
question, Michael?
I can.
Yes, Michael knows a lot more about solar energy than I do.
There was a
Solar
comment by Bill
electricity.
Byram. There was a question from Bill Byram, or not really a statement, in regards to ground source heat pump technology as far as being a more energy efficient application for heating and cooling. You have any comments on that?
I certainly do. As some of you know, we're in the process of building a high performance building for Mr. Byram at this time, my company Access Design Build, and we are using a 56 SEER geothermal heating and cooling system on his building. It also heats the hot water. This system with the federal tax credits was less expensive than an electrically driven multi-zone split system for both levels. So is it cost effective? Is it efficient? You bet.
You raised a good point regarding the tax credits. Does it receive the same level of tax credits as solar?
I think it's still 28%.
No, 26% right now.
26%. Yeah, you're right.
With
Yes,
the
it does.
potential of going back to back up to 30 if the bills for the Senate.
Yeah, but that depends on Washington, D.C. It's
No,
like
I
climate
realize.
change.
But
Yeah.
current is
It's really hard to predict.
Hey, Tony, there was another question about whether you recommend or your thoughts on thermal mass concrete floor heating.
Thermal mass concrete floor heating. Actually, we did a building once when I was in Arizona in Tucson where we did that. And it was very effective. We got to put it on the south side of the building. So it was like a collector. The floor was like a collector. We also were pouring the slab. So we ran a polyethylene pipe system through the slab. And then we circulated water from a solar hot water heater panel system on the roof through the slab. So we got two bangs for the buck. We got thermal mass absorbing heat on the south side of the building in the winter in Tucson. And then we had a fan system which circulated into the house. It was like a solar greenhouse basically on the side of the building. And then we also got to heat water through that system as well. So that can be highly effective. I think, it really has to be planned into the building right from the start, that kind of thing.
Understood. This is Phil. That was my question. We did a greenhouse exactly like that. I was just looking
Really?
at what the practicality of expanding it into, I guess, real buildings, kind of your domain was, what the interests were. Thank you.
Yeah, it's highly effective.
I want to bring everyone's attention to some great references to local builders. One provided by Tracy Wallace in regards to a SIP builder, and then another one from Eric Pratt in regards to ICFs. I believe I got those right. If not, but it's in the chat. And please remember that you can save the chat by clicking on the three little dots at the bottom of the chat there, and it'll say save chat, and it'll move it to however you save files on your desktop or on your computer. We have a question from James on building integrated PV or BIPV and integrated solar roof products in particular. GAF announced a new product last year where he provides a reference to it, but do you have any comments as far as how that's heading as far as in the marketplace?
I do not right now. To be honest with you, I haven't paid much attention to BIPV for the last couple of years. It was really expensive on a per square foot basis. So it just had very limited application. But, as time goes by, that's going to change. The cost per square foot is going to get down. And, that's what has to happen. It was like some of the very high performance glazing products that were available to us in the 90s when I was a manufacturer's rep. They were great products and highly effective, but we couldn't sell them here in the United States. Sell them in Western Europe because they pay for it there. But developers and building owners here would just not pay for it. They would not pay that premium for that kind of product. So.
Hey, Tony, what do you attribute the main energy loss through older windows? Is it the actual glass properties or is it the bad sealing? What are your thoughts on that?
Well, really, it's both. I mean, older windows have problems with seals. And you get air leaks. It's called exfiltration. It's a problem on all buildings, even commercial buildings. We found some amazing things going on when we did some testing on commercial buildings about 10 years ago, that they losing air conditioning through a lot of different places. It just doesn't take much. It doesn't take more than a pinhole or something the size of a dime. You can lose a tremendous amount of energy that way. It's kind of like, think of, you've got a faucet or a hose just dripping or running. I mean, it runs up in a hurry how much water you lose when something like that's going on. Same thing with your ducts in the attic. So anyways, yes, sealing is very important. But of course, the other thing is that older windows are all typically going to be clear, single glass, and energy pours through those both ways. I mean, You don't have to replace the windows. You can actually put really good storm windows on there, and then you have double glazing, which helps a lot. And is much less expensive than replacing all the windows.
I have a question, or not a question really, but like a fallback to the question regarding older Texas style ranch houses and improvements. And so one of the things is converting your lighting to LED lighting. Can you talk about the advantages of doing something like that, both on on heat and on power?
We do. As you know, LED is much more efficient electrically, but also the heat emitted by LED is drastically lower than any other type of lighting. We have one situation where that worked a great deal to our advantage, because you remember, a lot of people like recessed, can lighting. It's standard in commercial buildings, but people use it in residential a lot now too. So one of the problems that we had was the insulation codes changed. You have a recessed can, it's in the attic, you have insulation around it. The can has a sensor in it. It shuts the light off if it gets too hot. With insulation around it and an incandescent bulb or a halogen bulb or whatever, these were getting too hot on a regular basis, and the sensors were shutting off the lights, which is a problem because we're required by code to do what we were doing insulation wise, but the can manufacturers had made sensors that were too sensitive. How did that problem get solved? LED. All those problems went away as soon as we started putting LED bulbs up there. So yes, we talk about it a lot.
Thanks. So are there any other questions from our attendees? I mean, there have been some great questions here. I would like to take over the screen again and do two things. One, I would like to introduce a little teaser for our DFW solar tour in the fall. And so if you bear with me, I will share my screen again. So Tony mentioned Bill Byram's house, and we want to, it should be fully operational and up and running by our fall solar tour. But this is architectural renderings of Bill's house. And Tony and Bill, Bill, are you on? You want to talk a little bit about your house, both of you? But anyway.
Okay. Can you hear me?
Yes.
Yes.
Yes. So I've been working with Tony and Michael on both the house and the solar system. And is it possible for me to share anything?
Sure, we can make you a host, a co-host. What do you want to share?
I just want to share the solar panels sitting in my garage, which was a great, neat thing. So what I was going to share.
We don't have a roof yet to put them on, but he's got the panels.
Yeah. So what I was going to share was the fact that with the current situation in the supply chain, you can't get things very rapidly. And so I've had to order the solar panels, the battery, and my appliances, and I'm storing them in the old house garage next to my plug-in hybrid vehicle. And the reason is I ordered appliances back in early December, and I just received a note today that something isn't going to come in till way into May now.
Yeah.
So, everybody, that's one thing that affects all these buildings and upgrade projects you may have is the supply chain right now. And so you need to order things up early.
Definitely.
But yeah,
We've got problems getting most materials these days in the construction industry. I just wanted to comment here that on Bill's house, we're walking the talk here. We're not just talking about high performance building. We've designed and engineered are going to build this high performance building. And we're getting to do all the things we want to do on a high performance building here because Bill is very committed. And that's great. You know, we're doing a ventilated wall system. We're doing a ventilated roof system. We're doing cool roof panels. We're doing photovoltaics. We have a butterfly roof, which is going to collect all the rainwater and reuse it. We're going to do xeriscape around the building. So we're getting to do, and we also have a geothermal heating and cooling system. And we're getting to do all the things that you should be doing on a high performance building here.
Bill, you want to mention a little bit about your information of things as far as your controls in the house and everything like that?
I'm sorry, I missed one word. Say again.
It was just, you know, how you're going to be managing your energy use within the house.
Oh, well, I plan to use some equipment from Solarc, a company in Northeast Texas, which has now moved to Plano, unless they move again. And they have a smart control panel, which allows you to control 14 circuits. So it has current sensors in each of the circuits, and it can turn them on and off. So let's say you've got your house and the power fails. And how do you control all that? In other words, what if you go and try turning on the dishwasher because you forgot the power failed? You may not want to run the dishwasher when you're a low solar usage, maybe the clouds overhead and everything. So this smart control panel can control all that on these different circuits. It can do it automatically, and it can allow you to program it to set it up. So yeah, so we'll be doing that.
So we're pretty excited. Yeah, we're pretty excited to, you know, when the house is finished, and hopefully it'll be part of the DFW solar tour. And that's the whole reason we brought it up, is that we want to perk everyone's interest in that this is going to be a great event this next year, and we're going to make it a hybrid event, at least at this point in the discussion, so that you can physically go out and what we call kick the tires. So,
right.
And as you can see from the shape of the roof, I'm doing rainwater collection off the roof, but I'm trying to find local companies that have expertise in that. So if anybody knows of companies that have a lot of expertise in rainwater collection, please send the information to me. We're still collecting, figure out what we're going to do on that. Tony and I are. You can see the lines in the drawing there. It shows it in the backyard. Well, it actually doesn't show it. That's the geothermal. It shows it on the side of the house, rainwater catch.
Yeah, Texas A&M has been helpful, and we have a publication from them on rainwater collection, which is quite good, but we don't have contacts yet for someone to install the systems.
Fantastic. I anticipate it will be on the DFW solar tour.
Yay.
On the rainwater collection, the facility on Coit Road that Texas A&M AgriLife has got an extensive rainwater collection system that somebody installed.
Okay.
I would ask them who their installer was.
We will do it.
Obviously, they're not going to recommend this person because they can't, but they can probably work around that.
Yeah.
what was the name of that facility?
I politely raised my hand about 2 minutes ago.
Okay, thank you, Melon. Sorry about that. My fault.
Back to the question, I noticed on the house, on Bill's house, you didn't have solar panels over the garage. Was that because they're redundant, or the house is so well built you don't need them?
It's partially shaded there, Melon. You can't see from the, but there's some partial shading on the garage roof. That's why we're staying off that.
Okay.
Yeah, we can get, that actual rendering is not the current layout of the solar panels. That was just a representation early on. There's more panels over on the main roof. We're up to what, 15 kilowatts, Bill? Michael?
Right.
Yeah.
So we're up
Okay.
to the maximum we really need, 15 kilowatts, and we can do that on the two main roofs without having to go to the garage roof, which
Yep.
is shielded in the mornings.
So you can
Yes.
sell that space for advertising.
That's right.
Well, because of the butterfly roofs,
NTREG DFW solar tour. Big banner there on the
That's
garage
right.
roof.
There you go. All right, now, thanks.
Hey, Tony and Bill, Phil Timmons also was asking about whether the wind load, about the wind load on the north wall of the building, of the house.
Structural engineers, I think, engineered it to 120 wind load all around the building. It's 120 miles an hour, so
You know, one of the
that's
things.
not
about
going
that-
to save you from an F5 tornado, but
Understood, thanks.
A little bit, Bill, because you have those tall trees in the back on the north side, so it kind of slows the wind down, but it doesn't mean that those trees won't fall down, right?
true.
there's a
Phil,
lot
did
of,
you have a
there's
follow-up?
also, there's a lot of if you look at the structural drawings, there's a lot of bracing there. for
And
wind.
that's what I was wondering, how much overhead that created by that design, and if you could have shielded it somehow. But you answered the question in general. It just seemed like oh wow, here's something we got to catch, and does that increase by choosing that option, the cost trade-offs?
Yeah, there's a lot of engineered lumber in this building, and there's a lot of wind bracing in it too. So that's how the structural engineer worked it out.
Michael, thank you for bringing up the Bill's house and the DFW Solar Tour, which is our
Yeah.
signature event every year. Any other questions?
No, there's been some great comments and directions for information in the chat, so please remember. I want to thank Kenny Eteria, who is our intern. He made contributed a comment there, so thank you, Kenny, for joining us today. So I just want to direct everyone to our next meeting, and it's going to be a field trip, and we've coordinated this with Susan Alvarez with the city of Dallas, and we're going to have the opportunity to visit the Vickery Meadows Branch Library, which is an award-winning library.
Excellent.
Certified. But the presenters that are going to be there are going to be the architects and designers who were involved with the project overall. And guess what? We're going to be able to, if the weather is our friend, we're going to be able to get up on the roof and actually see the solar system.
Great. Fantastic.
Yeah, it's gonna, we've been pushing for trying to get back together for a while. And so we thought this would be a great opportunity to get people out. We're hoping the COVID is under control better at that point in time. So that's our next meeting. We look forward to seeing everyone there. There will be COVID restrictions in place, or there'll be a mask required by the city of Dallas. That's their current COVID protocol. If it changes, we'll let everyone know at that point in time. So don't forget, Saturday, March 12th. We don't have a time, but it's probably be 10 o'clock like usual. And we'll see what happens. If we all do get together, we've talked about, hey, it's an opportunity. We can go find a place to have lunch afterwards, which we'll be able to socialize as well. So stay tuned for more programs coming down the pipe. And congratulations to the new board. Looking forward to working with you. And I'm going to close it with Rosa.
Thank you, Michael. First,
Michael.
Tony, thank you for that absolutely terrific presentation.
Thank you so much for the opportunity. I really appreciate it.
You bet. You kept the audience with you the whole time. and their
That's not
words are
easy to
fit-
do.
It's not, but this is a great group with great questions, and
Yes.
we truly appreciate it. Thank you very much. Let's everybody
Thank you
give
all
Tony a
for
round of
coming.
applause. Thank you so much. Can't do this without you
Thank you, Tony.
guys. Thank you. And then as a closing item, again, I want to thank you all for letting me lead this group for the last 4 years. It's been an honor, a privilege, a challenge. And I want to give our new chair, Mark Whitty, a few minutes to say a few comments. I am so grateful that he is taking over. I know he will be great and that the organization will continue to thrive and grow. So Mark, do you have a few comments for our group and close us out?
Yes, thank you, Rosa. I appreciate it very much. For any of y'all that were not aware, I was out hiking and camping in the Big Bend area over the last week or so. And when I got back, I was surprised to learn that I was a candidate for board chair position. And not only was I a candidate, I was the candidate, which makes it a little harder to lose an election. And so now I have the unenviable task of trying to follow up someone that was absolutely tremendous and sublime, and the way she ran the organization for the last several years, 4 years to be exact. And so I'm going to be leaning on fellow board members, just members in general, to help out, because not only did Rosa do a tremendous amount of work, her husband, James, did a phenomenal amount of work as well. They were a team and they did a tremendous job. And I want to actually applaud all the effort that James did as well over those 4 years. And so I'm really going to need a lot of support from fellow board members, like I said, and other members of the organization. I'm going to schedule the board retreat sometime between now and the March 12th meeting so we can get together, the continuing members and the new members. And I would like to have an in-person board retreat. You know, as Rosa and Michael said, we're trying to get back to having in-person meetings, and going forward, we're thinking it's going to be a hybrid. It's going to be in person, but we also want to find a place that will allow us to live stream the meetings so that other individuals that can't make the meeting for whatever reason can still attend virtually. So that's going to be one of the things that the board needs to work on to try and find basically a permanent home for NTREG when we aren't having field trips. But as a run up to that, I would like to have the board retreat in person. And we haven't had that in a while. So I want to be able to hopefully have a board retreat scheduled someplace where all of us can get together and meet. We can get introduced with the new board members, have everyone give us an opportunity to talk about what we want to achieve going forward. So I'll be in touch with the other board members in the very near term to discuss that. And okay, Rob sent in a question, are we not going back to the same place? No, unfortunately, the church that we have been meeting at most recently before we went virtual has considerably increased what they want to charge us to meet there, to the point where that doesn't fit within our budget to meet there anymore. So we're going to have to find a new home. And again, we want to find some place where they have the available technology to live stream the meetings going forward. And we'll keep everyone apprised of that. If anyone is aware of a place that is centrally located that has capability to live stream the meetings, please let us know and we will go meet with them and see if that might be an opportunity for us to hold our meetings there going forward. But at any rate, look forward to, yes, sir.
What's the average capacity required for a meeting? Number of people, do we know?
We think it's around 30 or 35.
Okay, I'll ask around for that.
Okay.
Well, yeah, I mean,
That's
gotta turn Greg's. Sorry about
Any-
that. This is Lissa. When people are meeting in person, we've sometimes had quite a few more than 30.
Yeah.
It might take us a couple of months, but we could easily work our way up to 40 or 50. So.
Okay, well, we better say 50 then.
Yes.
Yep.
We need
Melon, you raised
capacity
your
for
hand?
50.
Yeah, I would say that we've had up to 75 or 100 people, but
Yes,
the average is 50,
right,
or it was, until COVID struck.
right. It was pretty high.
What was the budget? I mean, what was NTREG paying the church previously for 2 hours?
It was,
I think it was $600 a year.
yes,
$600 a year?
Yeah.
yes.
So that's 12, 10, 11 meetings.
And City of Dallas might be able to offer a library somewhere in, I don't know.
Right.
We had held meetings prior to the church, like at the library in Irving, which is centrally located between Fort Worth and Dallas, which would maybe enhance membership that way as well. But right now, we are primarily focused on Dallas. But any suggestions would be greatly appreciated.
No, Irving's better.
Interrupt. Don't really
Listen, I'm sorry, Lisa.
Sorry, I've
Go
just got to
ahead,
interrupt.
Melon.
We're used to doing no, okay, you first.
Lissa?
Oh, I'm just encouraging a central meeting location. I think it's more fair to meet in a place like Irving, because we really like to allow people from Fort Worth to get to our meetings without having to travel for an hour.
Right.
So if they're residents of Irving or Arlington or something like that, that could look into their local library or some of the community colleges in between. It used to be that we couldn't afford to pay any fee, but we have a little bit more wherewithal now, but we don't want to get ridiculous about it.
No, that's what I was going to say, Alyssa, is we were sort of gypsies for a long time. And the public libraries would limit us to so many times a year. So that was the creative part of being a program coordinator. So
I wonder if Mountain View College would be an option.
Tony, the challenge with Mountain View has been that, especially with COVID, if they're not in session, if they don't have classes, and again, they may not be having classes when we're meeting,
Right.
they don't want to have to be staffing security and so forth for us to be able to get
Got
it.
it.
So
This
that
is
has
Saturday.
been the challenge with the universities. Yeah.
Bill?
So, yeah, I live in Irving. I'm familiar with some organizations that have used the Irving Parks buildings. And a few organizations have done things at the Irving libraries. I will check with the Irving library system and some other city things and see. One question, do we have a 501c3
Yes, we do.
letter,
Yes.
IRS letter that's recent within the last couple of years? They're very horrible on this. If you have one that's 5 years old, they won't take it.
Really?
The city of Irving, they require one that's very recent. I'll have to look. I think maybe it's 2 years. So do we have
Yes, we do.
But
have a-
ours is 5 years old, probably, Bill.
think so?
It might be 4 years old.
Well, we
That's
had this
when-
problem. We had this problem with the city of Irving for a group. And right now, getting a letter from the IRS, a 501c3 proof letter, takes a long time. IRS
Everything
is
does.
backed up so horribly. So that may be a problem, but I'll look into this some more. We've had a problem with another organization.
We might have, we might be able to provide them on a confidential basis, a copy of the 990 tax return. No,
That
they
wasn't-
don't-
They were very horrible about
Mm.
this, the city of Irving. I will check again, but we had a problem with a club because of that, the
Huh.
time scale of the letter. It was too old.
Wow.
But
You
I'll
can't
look into
argue,
it.
you can't argue with a recent tax return.
Yeah, I know.
They
That's a-
can.
That's a certification of your organization.
They
That's
changed personnel and the new person in there said, we required this one document. If you don't have it, we don't care. We're not going to do anything. It's horrible. We'll see what we can do.
Okay,
figure it
Melon,
out.
you raised your hand again?
Yeah, Irving West Library was one of my favorite locations for a meeting.
Really?
And-
It
But they limited the number, well, I think I actually had to join them as an out-of-town member to be able to book the room.
Well, again,
So-
it's, the
Yeah,
new
but
board is
anyway.
going to be
it's
working
a
on
great
that.
location.
I'll work on it.
Yeah, Bill's a longtime resident, so.
Yeah, okay.
You should at least consider contacting Jim Shrevner, who built Lady Bird Johnson Middle School.
Oh, that's
Um,
another great
Good
choice.
idea.
That I know they use that building a lot after hours.
Yeah,
Really?
good idea.
You know,
Good idea.
would it be available for weekend activities?
I have no idea.
They
Was that-
hosted us once, Michael.
Yeah, that was
Remember?
our last great field trip was that facility. So,
Yeah.
I mean, it's a great choice.
And
Okay.
what better place to have renewable energy meetings than Lady Bird Johnson Middle School, so that maybe people would understand that the school systems ought to be building net zero buildings.
Yes, yes.
Let's turn it back to our fearless leader, Mark Whitty.
No, I just have to say that the Irving West Library is the first net zero public building built in Texas.
Really?
Check it out.
It could be good.
Yeah,
I will look into all those things.
thank you, Bill.
Hey, Bill, I'll follow up with you too.
Okay.
Bill, for everyone's understanding and remembrance is that Bill is new on our board, so it's
Right.
great to have him.
Yes.
participating.
Okay, well, we are running a few minutes over today, but again, I would like to thank Tony Robinson for his great, very informative presentation. Thank you, Rosa, for getting the meeting kicked off and for everything you've done. And thank you, Michael, and everyone else that have contributed to the ongoing success of the organization. And so with that, I will end the meeting and I'll be in touch with the board members soon about our retreat. And otherwise, we'll see everyone in March.
Thank you,
Have a
Mark.
great
Thank you,
weekend.
Mark. Thank you.
Thank you all.
Welcome. Congrats.